Mission Control, we found our last crew member.
I've always wondered what space is like.
Welcome to space.
Wow!
Yeah, it's pretty amazing.
Wow!
Okay, so space.
Wow!
Stop doing that.
Okay.
So basically, space is this big thing we've got behind us here. It's practically the entire universe, and everything we know that exists is inside of it. It's made up of all things such as planets, stars, satellites such as moons, and galaxies and solar systems which contain these things. Planets orbit around stars and moons orbit around planets. Sometimes we have things like black holes and wormholes and other phenomena that occur in the solar system, galaxies in space, and are incredibly rare to find.
Space is so cool and it's full of all sorts of things. What is each of these dots?
Pick one to find out about. You've picked Kepler 22b. Here's George to tell you more about Kepler 22b.
No, don't leave me.
Hey Joe,
Hello.
I'm George, and this is Kepler 22b, which is a type of planet. Scientists think we might be able to live here because it's also near to Earth. Earth is a very special planet because it has liquid water, which is a critical component for life on this planet. Our moon is also very special, and it is a captured planet, which also has a big impact on life. We have a large iron molten core with a solid inner core, which is a critical component of our magnetic field which shields us from harmful rays from the sun. Our planet is also the correct size to have enough gravity to hold onto our atmosphere without being too big, so that the atmosphere would contain many more poisonous gases. Furthermore, we have a tilt of 23.5 degrees, which is ideal for our planet. If the tilt were more, then it would make the seasons more extreme. Also, our rate of rotation is 15 degrees per hour. As a result, we have a relatively small change in temperature from day to night. By contrast, our moon has a rate of rotation of 0.5 degrees per hour, and the temperature extremes between day and night are far greater. Likewise, Venus, a planet very similar to Earth in many ways, has a rate of rotation of about 1 degree per day, and the temperature swings between night and day are so extreme that it will pretty much wipe out life as we know it on this planet.
Bye, George.
Well, I hope that was helpful. Next up, we have stars. And here's Damon to tell you more about stars.
Hey Joe, I'm Damon. Now let's talk stars. Stars are everywhere and they're really important because, well, our sun's one of them, and it's really important because it provides our planet with heat, energy, and something to orbit around, otherwise we'd just be floating around uselessly. And, well, quite a few things more like lights. Now, let's talk something else. How about the R1365A1? You don't know what that means. It's a really big sun, kind of like our planet, but a lot bigger. Well, you know we can't look at our sun, well, for too long anyway. Well, we can't look at this sun for 1 second at maximum, because otherwise we'd go blind. And, well, I've already told you that its names are the R135A1, but that's not very useful. Its brightness is quite amazing. You can't even imagine how bright it would be. And, well, it's 10 million times brighter than the sun, so that's pretty amazing. And it's also 265 times bigger than our sun, so that's pretty cool. We were able to view it from Sheffield with the Hubble telescope, and it's almost 22 million light years away. So we couldn't get there because even though it's only a young star, which means it's only recently been formed, it's going to die very, very quickly. So by the time we get there, it will most likely be dead, which means it could create a supernova, but we'll have someone else tell you about that, don't worry. It can also be up to 500 times the sun's size, which is pretty amazing. And it's going to burn so quickly and die, like I've already told you, that no planets could orbit. Well, that's all I've got to tell you. Bye.
Bye.
I hope that was just as helpful. Now, earlier, I told you about these things called moons.
I never realised what was actually out there. This is so amazing.
A moon is something very special to a planet. It's like another planet orbiting a planet. It's quite weird when you think about it. Satellites are something that orbits a planet as well. We've made man-made satellites. This is a type of satellite, it's a natural satellite. Now, the phases of the moon are very interesting because when they orbit the planet, due to where it is in retrospect to the sun, we can't always see the whole part of it. We have things like it goes in a stage of a waxing gibbous, which is where we can see a quarter of the moon, so half of it is, or the bottom bit that is covered up. But before that we have the first quarter, which is where half of the moon is completely covered by the night sky. And we also have the waxing gibbous, which is the same as a waning gibbous, only the other half is missing. We also have last quarter, where the other half of the moon is covered. We have the full moon, which is this, where you can see everything. And we have new moon, which is at the start of the month, where everything is completely black and there's no moon in the sky, which is where the moon is off behind us in relation to the light. The moon itself is very old. It's nearly as old as Earth. It's born around the same time as Earth. It occurs because it occurred when another planet crashed into us and parts were fragmented off, causing a moon. And then these are how most moons are caused. Now, space is really, really interesting, and this is just one of the reasons why. And that's why you're here, Joe. We're sending a satellite to Neptune, and we're going to the International Space Station to monitor its progress. To let you know about rockets and how to get to places in space, here's Michael.
Hello, Joe. You may have realised that you can't just jump into space. You need some pretty high-tech equipment. We tend to use rockets. Now, you may think that a rocket is just, well, what you see on TV that goes into space. But there's different types of rockets. I mean, there's a missile spacecraft, which is what goes into space, normal aircraft, we call rockets, and other vehicles which obtain thrust from a rocket engine. Rocket engines push rockets forward simply by throwing their exhaust backwards extremely fast. And a rocket engine exhaust is formed entirely from propellants carried within the rocket before use. Rockets are relatively lightweight and powerful, capable of generating large accelerations, and can attain extremely high speeds with reasonable efficiency. Rockets are not reliant on the atmosphere and work very, very well in space. Chemical rockets are the most common type of rocket, and they create exhaust by the combustion of rocket propellant. Chemical rockets store a large amount of energy in an easily released form and can be very dangerous. However, if you use careful designing, testing, and construction, you will minimise these risks.
Right. Awesome. So, Neptune, what's it like?
Well, this is the satellite we're sending to Neptune, and this is Neptune itself. Here's George again to tell you about Neptune. He knows our planets.
Well, Neptune is actually just a big ball of gas, mostly helium. Due to this, the planet is really cold, to the point of even being minus 218 degrees Celsius. Not only that, but Neptune has 13 moons. A day is 16 hours, 6 minutes and 36 seconds long. A month is 7,680 days long. And finally, a year is 164.79 years long compared to Earth. Also, we can't send astronauts there because the main dangers that they'll be facing is freezing to death, unable to breathe as the air will freeze and rapidly die.
Awesome. Bye.
Well, Joe, that's everything you need to know for now. Quick, get out of the way before... Blast off!